All right, so let's take problem number 6, which is having a string and trying to get the consonants out of that string. All right. So first of all, it's telling you that you can use the isAlpha method, isAlpha string method, meaning that this method only works in strings, right? So why do we need this isAlpha? Because simply, what if I had something like this, symbol right there, right? Or what if I have something like something that is a number, for example? I don't want to bother and check if these are not vowels or not, because they are not even gonna be alphabets to begin with. So they are not going to be either consonants or vowels, right? So stuff like symbols and numbers, we don't really want to get involved with all of these things, right? So let's just try is alpha like that, right? So this is going to tell you that this is for sure this is an alphabet, this is not an alphabet, this is not an alphabet as well, right? So we can just start from there and let's make a function. This is the iterative version. So let's call it define get consonants iterative. It's a very long name for a function, whatever. So it takes a string, right? So let's take this string, right? And this is my string. Now this is my string, like that. I'm just gonna take away these parts. All right. So let's say for I in range, and I'm just going to traverse these elements by the indices, right? So let's check. First of all, is that element is alphabet, right? If it's an alphabet, then let's check. There is a Pythonic way to do this, like using the n operator, which is basically a linear search. This is implemented via a linear search, right? So it checks, is this equal to one of the vowels or not? So I can, using the shorthand method, I can just say something like that, right? But we know that this is only gonna be working in Python, so let's do something that is language agnostic and can work across multiple programming languages. Is this recording? It's recording. All right. So the longhand version can be something like this. Is this not equal? Remember, we are looking for consonants. Is this not equal to A? And is this not equal to E? And so on. And you get the idea, right? So it's just and I and O, and what do we have left? I think there is a U. Yeah, right? If it's not equal to any of those, then this is possibly a consonant, right? So we can just print the that element, right? And let's make that we have an end of white space, right? So let's call the function now. Get consonants iterative and just pass as. And you will find that you have the same result, but without any of the vowels right there, or even the symbols, right? So this is the iterative. All right, so let's take the recursive version. I don't really need to use the call stack method or the stack diagram method because I think this is fairly simple. So let's just say get consonants. There are two ways we can do this. Like the problem is stating here that you can do it using optional arguments. This is the first one that we're gonna do, but you can use it as well. You can do it as well without any optional arguments, just with the past string that is gonna be worked on, right? So let's have the first method, which is basically the recursive method, but this is what we're talking about is part A here, right? So we don't really need the loop, right? But I think we still need the same part right there, right? So what is going to happen is that, see, this index is incrementing every time inside the loop that we have literally just commented out, right? So we need to make sure that we have an index. So let's have the index of, for example, something like 0. So start from 0, 1, 2, 3, up to the last element, right? So you can tell that this is the base case, by the way, right? So if I became equal to the length, right? Equal to the length of s, right? Which is, if this, I don't know, maybe this is 16 or something. If this became something like 17, so we are out of range, we can just return what you guessed it, return none, right? Or you can just leave it return like that. So why is it returning none? Because remember, in this program we are just printing. The sole purpose is just printing. We don't really need to return anything. If we were returning the actual string, without any consonants, then yeah, in this case we're not gonna return none. We're gonna return something that's not going to affect the concatenation of the elements in the string, right? Which in this case I'm referring to something like an empty string, right? But you're gonna see this in the extra example when we take on a string and try to reverse it, right? But for the time being, we're just printing here, just the sole purpose of printing. There is no need to return anything else. So accordingly, the conditional return in the base case is going to return nothing, right? So let me just indent this, remove one indentation level because we do not have a for loop anymore. And we know that we are going to recursively call get consonants, but we are sending in that recursive call s, and we are sending as well I that is being incremented as 1, right? Seemingly everything should work now, right? So let's try and call get consonants and pass that s to it, and it's going to tell you that this is the same result as that one, right? So this is fairly simple. Now let's take a look at doing the same thing, but instead of using an optional parameter, instead of using that optional parameter I equals 0, incrementing the index every time, there is another way to do that, right? With only having the string being passed, right? So how can we do that? Right, so now let's have a look on the method that we can use instead of using an extra optional parameter. How can we do the same exact algorithm without adding an optional parameter, just using the string, right? So let me just leave everything as it is, but let's go to the whiteboard here. Right, let's write some pseudocode that describes the same algorithm that we were working on. But let's just state something at the beginning. We said that what we have done is that the first when we were solving this is not gonna help. When we were solving A, right? We said that we will increase. Come on, increase I or the index, right? While fixating the string itself, whereas so when we called the recursive function, or every recursive function had this following shape, right? The function name, which is get consonant or whatever, and the parameters that had s and I plus 1 as the index, right? So the index will, for example, if we have banana, right, the index, come on, the index go from B to A to N to A and so on, right? What we will do for B is the following. We're not going to use that approach. What we will do is that fixate I, right? And by fixating I mean that we are always going to check the first element, which is, you guessed it, index of 0, right? So we're going to always have this kind of look. We have the string, so we always are checking the index of 0, right? And in the same time, we're gonna, I wouldn't say increase string or manipulate string. I would say something like slice the string s, and this would take the shape of the following. When you are recursively calling get consonant, it's gonna take only one parameter, which is the positional parameter string. There's no optional parameter as this guy, right? So how would this look like? Now let's write the definition for define get consonant, right? And let's say that get consonant is gonna take only the string, which is one positional
argument, right? So let's say that the string is basically something like banana, all right? And in the driver code, let's say that this is the definition, and in the driver code, this is the driver code, we are going to call get consonant. And remember, what we are doing is that we are only printing here, right? So get consonant is going to be called while passing the S or banana, like that. You could have just written S like you have written here, but whatever. Alright? So in the first function call, this function is going to be called, right? It's the same thing, by the way, as the stack diagram that we have said that we have taken before, but I'm just doing a different structure for it. So here we will have the base case, which is typically the same thing as before, right? So the base case is basically if we reached that the length, there's no length anymore, right? The previous one where we had I there while we were increasing I, we said that the base case is going to be if I became greater than, oh, let me just say, if I became equal to length, then we would just, return nothing to terminate the program, right? This is not going to be any different, but I'm just going to leave it for now because now we don't have I. So how would we do the base cases? So let's just leave it for now, all right? And let's say that according to this technique, we are going to fixate I. That means that every time I'm going to check the first element, which is index of 0, right? So if I have S in this function call that is being passed, which is banana, then I would want to check the first element, right? I want to check the first element, right? So let's just say if that element, and that's the most important part here, if that element of index 0, right, was not in what do we have, U, then just print that element. Notice that there is no I here, so I'm just using the first index, right? And since this is not the first condition is not the base case, so the interpreter is not going to check this one, and it's going to go to this if statement, and it's going to see is that banana is not inside the vowels. Well, yes, it's not one of the vowels, so it's a consonant. So this is going to take place, and the screen is going to have. Let me see. Let me just add a small thing here because we want things to be printed alongside with each other. So we have n that is equal to white space like that, right? So we're going to have p being printed, right? And there is a space afterwards from that end here, okay? So now the interpreter is going to check the line afterwards, right? Which is basically, typically going to have the same call from the function, the recursive call from the function, the consonant. Okay, we should have just written this like this, right? And now we should pass S here. Now the trick, I don't want to write the answer because this is basically the answer for that second method or for only using one position argument. But if you thought about this for just 1 second, you're going to see something. What if every time I'm passing S, I don't really pass the whole string, but instead I pass what I want to check next? Meaning that if I have banana as a whole, the string as a whole that is being passed in the first function call, which is this one, this is the first function call, right? So this is, I don't want to say that this is the recursive function call, this is the first function call, but let's just call it as this is the first function call, right? So we have banana being passed as a whole. What I want to see is every time I'm fixating my pointer, on the first index, which is index of 0. So this means in the next recursive call, when this takes place, and the control flow is past this, right? Notice that the control is going to be stopped here. So when the control flow goes to the other version, I want to make sure that what I'm passing right now is typically something like this. There is no beat anymore, but what is being passed is like this, right? So we don't have a name anymore, right? Because we already checked that in the previous iteration or the previous recursive call, right? So how can we do this? Well, if you look closely, if you want to, after printing, right? If you want to minimize banana to be the same word without that E, then this means that you're just gonna need to slice it starting that index, right? So if this is index of 0, then you would want to slice it from index of 1 till the end, right? And this is basically the solution that we can write here. Okay, so if we are passing the string from 1, the next element after the one that we have just checked, which is index of 0, till the end, then we are going to pass the word banana like that. Then this is the string that is being passed to the other or to the next recursive call, right? So now we have that consonant that has S, right? And now that S that is being passed here is typically a banana without a B, right? All right, and the same thing will go. We don't know the base case here, so I'm just gonna skip this because we didn't reach the final element, which is A in this case, right? And now we can say something like this. We can just say if, and this is what the interpreter is going to run afterwards. It's not gonna run this at base case. We didn't reach the final case, right? Or the stopping case. So if S of 0, which in this case it's gonna be the pointer at index of 0, fixated on the first element. And this is what I mean by fixating the index or fixating the pointer at index at 0, right? And slicing is every time. So the first recursive call is gonna have the full string, right? So now we can send to the next recursive call, we can send banana from 1 to the last element, which is from this part till the end, right? So we are sending banana like that, right? So we have the next recursive call having S to be banana, right? And this A is now, since it's sliced, then this is my index of 0, right? So the next time I go to the third recursive call, right, I should be passing the string from the next element or the second element till the end. And from the second element, which is 1, this is going to be an A and A, right? So this is going to be sent to RC3, right? So the S is going to be like that, right? And the next recursive call, we're going to send S from 1 till the end, right? So 1 is here and this is 0, so from this to the end, so A and A. So the next recursive call is gonna have S that is equal to A and A. And every time we send a sliced version, a modified or a minimized version of that string, we can just check now if that's passed or if that's sent slice of the string, if the first element of it is it consonant or not. In the next recursive call, the first element, is it a consonant or not? In the next recursive call, if the first element is a consonant or not, by fixating the index at always at index of 0. But what is changing here is that we are slicing, we are minimizing the string that is being passed, right? And here, obviously, we are sending, didn't complete that one, right? And this is basically A and A. Okay? So here we're gonna see index of 0, which is in this case is gonna be A. is it not in the vowels? I'm just gonna write vowels for short. You know that the vowels I mean by this part. If it's not in the vowels, then just print that s of 0, right? So it is not one of the vowels, or is it? It is one of the vowels, right? So this if statement is not going to execute anymore, and nothing is going to happen, right? So we're going to go to the function call, or recursive function call, and see that there is get consonant, right? And now we should think about a way to send the same word, the same anana, without the first index, by slicing this from 1 till the end, right? Because we have checked already the index of 0, we don't really need it anymore in the next iteration on the next function call. So we can just say that we are passing the index sliced from 1 till the end to the next function call, right? So let's go through another one. I think I'm going to run out of space here, but I think you realize the idea. Right, so the control is going to stop here, and the control is going to be sent with the value of s is going to be sent as nana, right, starting this to the end, and this is going to be my third get consonant, right, and s here is going to be typically nana, right, so this is s. All right, and this is the base case that I'm not really aware of till now, and this is the conditional is the first element, which is index of 0 here, is the first element, which is in this case n. Is it not in vowels? Well, yeah, it is not in vowels. Then this print statement is going to work, and we are going to print s of 0 with the space afterwards. So we're going to print n like that. There's a space. This is your screen or terminal. and now we're going to go to the function call, or recursive function call, get. Let me just use a different color here. Get consonant, and send s starting from the slicing of the second element till the end. So we are slicing from a till the end because this is index of 1, right? So now we are triggering another recursive function call to, we're sending the control flow to the next recursive call. If this is recursive call 2, then this is 3, and this is now 4, right? And here we are sending from 1 to the end, so we have a and a as s, right? So we are defining get consonants that takes s, right? And s in this case is basically a and a, and we want further to investigate index of 0, which is a. So this is the base case that we're not going to check for now, and this is because we didn't reach it yet, right? And this is your typical check is now a index of 0, which is a. Is it not in vowels? Well, in this case it is in the vowels, so we're gonna skip this, nothing gonna be printed. And now there is another function called for get consonants, where we are slicing from the next second element till the end, right? So we are slicing from from 1 till the end, which is in a, right? So now this is gonna call another one. Let's just have this colored with black. So this is my fifth recursive call. Alright, so we are sending here s that is equal to from n to the final element, so na, right? So now this is my s, na, and this is get consonant,
right? So this is the base case. We're not gonna check it now. Now this is the conditional. Is in this case we are looking for index of 0, right? So this is index of 0. So is index of 0 not in vowels? Well, in this case, yeah, it is not in vowels. So we are going to print the n, which is s of 0, right? So this is gonna print the n with an s of 0, right? And afterwards there is a space. And finally we have another call for get consonant from the second element of the n. This is the slicing, right? So we don't really need that, we just need the a, right? So we have another call. I'm running out of colors here, right? To the get consonant of s, where the past string is typically only a in this case, right? So there is a base case that we're not gonna check, right? And now we can say if s of 0, which is in this case we only have one element, is going to have index of 0. So if it is not in vowels, then print, which in this case a is one of the vowels, so this is not gonna happen, right? And finally we can stop actually here, right? We can stop here, or I think it is better to stop at the next recursive call. And I'll tell you what, because if you stopped here, if you said that if the length of the elements, if the length of s is 1, maybe you're not gonna be able to check that element. But if you were to completely slice that string to have it ending up with an empty string by the end, maybe this is a good base condition. So let's call get consonant and just slice that string for one last time. So you're gonna slice it from 1, which is doesn't exist to the end, right? So this is gonna tell you, or this is gonna call right? So this is gonna call another recursive function, which is recursive function of 7, right? With s equal to an empty string. There's no white space here, it's just an empty string, right? So let's say get consonant, right? S is gonna be an empty string. So now let's check the base case. So the base case is gonna be something like this. If len of s is equal to 0, meaning that you have an empty string, then this is the time to terminate the problem, and this is the time to return none, right? So once we hit this line, because now the length is actually 0, there's nothing in that string, right? So you're gonna find yourself popping this from the stack and returning here instead of that called none, right? And we have actually ended our printing to the screen. We have printed the consonants that we wanted, and then this is when this returns none, the control flow is gonna return to this line. There's nothing afterwards, so this is gonna be popped of the stack as well, returning nothing at all. So this is gonna return none, and this is gonna be when this control flow returns to this function call, it's gonna there's nothing to execute after this line, so it's just gonna pop up the stack, returning none here, right? And the same thing will apply. There's nothing after this line when the control flow goes to this frame here, so it's gonna pop, returning none at this place, right? And here, let's just pick this color. After the control goes back to this stack frame, there's nothing to execute after this line, so it's just gonna return none to this part, right? So this is gonna return none like this, and then the control flow is gonna go back to the first frame, or the second recursive flow, which is this guy right there, right? So there's nothing to execute after that line, so it's just gonna return none as well, and it's gonna be popped out of the stack. So this is gonna return none, and this is gonna be popped, and this is gonna return none. The control flow will go back to this guy, and this is gonna return
this is gonna return none as well. So if you try to print that, this is gonna return to you none, right? But we don't want to print it anyway. We just want to print the actual
first index. That's it. All right. So let's take the same thing, but now we would say if the length became equal to 0, then return none. We don't have an I anymore like this. We don't have an index anymore. And the same thing applies here, right? The same thing, the same exact thing applies, but we don't really have an I. Oh, this is gonna be hard to edit, but whatever. All right. So there is no I, but we have an index of 0, right? And we are calling the same function while we are truncating the first index that we have already checked and printed if it was a constant, or not printed if it was a vowel, up to the very last element in the string, up to that there is no string or no characters anymore in that string, right? So if we run this, you're gonna see that this is the same result.